Right, here's the solutions to paper 2. Question 1. We know the starting value is £240,000. We know it's increasing by 2.8%, and we know we've got to do it for 2 years. So 100 plus 2.8% is 102.8%, which as a decimal is 1.028. You've got to do that to the power 2 and then times it by the starting amount, and that gives you on your calculator an answer of £253,628.16. No rounding asked for. Question 2. We have a function f of x equals 3x add 2. We've got to work out when the function is equal to 23. So putting a instead of x gives us 3a plus 2 is 23. 3a is 21, so a must be 7. For question 3, it's a cosine question. Okay, we have the diagram similar to this. 1.2, 1.35, 35 is the angle. We're trying to work out side C, this one here. So the formula we're going to use is c squared is a squared plus b squared minus 2ab cos c. So putting the numbers in, 1.2 squared, 1.35 squared, minus 2 times 1.2 times 1.35 times cos the angle 35. All of that on your calculator comes out to be 0.608. If you square root that, that gives you an answer of 0.78 kilometres. Question 4. Of the vector u, which is 6, negative 13, 18, and we're asked to find its magnitude. Well, we find its magnitude by doing the square root of 6 squared, negative 13 squared, and 18 squared all added together. So that's 36, add 169, add 324, square rooted, which is the square root of 529, which your calculator tells you is 23. Question 5, another vector question. You have vector p and you have vector q. Now that's how the diagram gives you. I'm going to take q and I'm going to actually add it to the end of p. So my q is going to go there. So the answer I'm looking for is this answer here, across there, which I can use my little diagram to say you go left 1 square and you go down 2 squares. That's using the diagrams. If you want to do it purely using numbers, then vector p in the question is 5 to the left and 3 up. Vector q is 4 to the right and then 5 down. And then if I do p add q on these numbers, negative 5, 3, add 4, negative 5, that gives me negative 1, negative 2, which is just exactly the same as what I got from the diagram. Question 6. The volume of a sphere is 4/3 pi r cubed. So that's 4/3 times pi times, now the radius of the earth, it tells us is 6,400. And if we cube that, do that on the calculator, we get 1.098066 times 10 to the power 12, which if I round it off, I get 1.1 times 10 to the 12 kilometres cubed. Part B says how many times is this bigger than the moon? So take the answer we just got and divide it by the moon. And if you do that, it comes out to be nice and simple, 50 times bigger. Question 7. Fraction question. 5t over s squared, over s divided by t over 2s squared. Well, when we divide fractions, we turn the second one upside down, make it into a times. What will cancel? There's a t there and a t there, it will cancel. There's an s here, which will cancel with one of these s's here. So that leaves us with 5 times 2, 10s on the top, and 1 times 1, 1 on the bottom, so just 10s. Question 8. It's a discount question. So discount means you do the full price, take away the discount. So 100% take away 15% is 85%. Reverse percentage, going backwards, how do we do them? Take the price that the person paid, which was £297.50, and divide that by 0.85, and that gives us an answer of £350. The other way to do it is that 85% is equivalent of £297.50, 1% is £297.50 divided by 100, and then, divided by 85, and then 100% you're looking for before the sale price. Take that number, times it by 100, and you'll still get the same answer, £350. Question 9. Similar triangles question. So take the two triangles that they give you, split them up into a big triangle and a little triangle. We know that this side here is 30. We know that this side here is 24. We know the area of this one is 400. Let's find the area of this one. So we need the linear scale factor first of all. And the linear scale factor is equal to 30 over 24, which cancels to 5 over 4. You don't have to cancel it, but it cancels to 5 over 4. So the area scale factor is 5 over 4 squared. So the new area is the scale factor 5 over 4 squared times the old area 400, which comes out to be 625. Now that's the whole shape. But remember, the question was given with the two triangles inside each other, and it's only asking you for what's the area of this end part here. So what we need to do for that is to get the area of PQTS is take the big triangle, 625, take off the little triangle, which is 400, and you get left with the required area, which is 225 centimetres squared. Question 10. It's an arc question, so we have the arc formula, which is angle over 360 times pi d. What information do we know? We know the arc is 28.4. We know the angle is 65. Pi is pi. We don't know what d is. So if I rearrange this to get the 65 over that side, the 360 over that side, the pi over that side, I'm going to end up with d is equal to the 28.4 times the 360 when it moves over, divided by the 65 when it moves over, divided by the pi when it moves over, and all of that comes out to be 50.06. Question wanted the radius, so we need to half that number, 25.0 centimetres. Question 11. We have a hexagon. We are told that the diagonals are equal to 40, so that means that each little line must be 20. All these little lines here are 20. Because it's a hexagon, then if I take out one of the triangles, we know that's 20 now, then this angle in here must be 60, because it's 360 all the way around. Now the area of a triangle is half side times sine the angle, which comes out to be 173 point something. So the total area is going to be that number times 6. If you do that number times 6, you get an answer of 1039 centimetres squared. Question 12, circle question, diagram similar to that. What does the question tell us? The question tells us that the total distance across there is 1.8, so each part is going to be 0.9. The radius is 1.2, that's 1.2. We are asked to find that total distance there, so basically we need to find that little distance and then add it to 1.2. So if I take out this triangle, put the information on we know, this is 1.2, this is 0.9, we're trying to work out x. Pythagoras, 1.2 squared minus 0.9 squared, 1.44 minus 0.81 is 0.63. X is the square root of that, which is 0.8 metres. The answer you're looking for, remember for the depth, is going to be 0.8 add 1.2, which is 2 metres. Question 13. Okay, we know that the inside is 9 by 13. We know it's got a border of x all the way around, so we can work out that distance there is 13 add 2x, and we can work out that distance there as 9 add 2x. Okay. Now the question says write down an expression for the length. We've just done that. We're also told that the area of the whole card is 270. So if I now take these numbers, the 9 plus 2x and the 13 plus 2x, and multiply them together, then that should equal 270. So I'm going to write it as 2x add 13 times 2x add 9. That's got to equal 270. So if I remove the brackets, I get 4x squared, 2x times 9, 18x. 13 times 2x is 26x, 13 times 9 is 117, equals 270. Bring everything over to this side and tidy it up. 4x squared, 8x, add 26x is 44x, 117 take away 270 is a minus 153, equals 0. For the second part of the question, then we need to take that answer, that 4x squared plus 44x minus 153 equals 0, and solve it. How do we do that? We identify the A, the B and the C. That's 4, 44, negative 153, and plug it all into the formula x equals negative b plus or minus square root minus square root b squared 4ac all over 2a. And I'll just tell you quickly that that should all come down to an answer of x equals negative 6.9 or x equals 1.4. Now the 1.69 is impossible because it's a negative answer for a length, so we just ignore that. So the final answer we're looking for is x equals 1.4. And that's us done.